All right, so let's try something new. So what I'm going to do is I'm going to attach this battery pack, which has four 1.5 volts batteries in it, to this circuit. I want to figure out the current through all of the resistors just to make my life difficult. So, what are we going to do? Well, we have to figure out what we mean by current through each one of these resistors. Well, let's just think about it this way. What's coming out of here from the battery? We have our total current. What's coming back in? We have our total current. And then the current going through each one of these has to somehow add up. So I guess this is going to be I2 because this one's 2 ohms. This will be I1 because it's 1 ohm. And this will be I3 because it's 5/6 of an ohm, or because I've already got 1 and 2, really. And then I have to figure out what to do with these. Well, the first thing I can do is, I know this is the same as this, because we don't want charge accumulation. And therefore, also, it's the same as the current coming out of here. Actually, the current coming out of C. That sounds weird, coming from me. So, I3 is the total current, right? So, all we have to do for the total current, for I3, is use E equals IR. So that is going to give me, let's see, E is equal to 4 times 1.5 volts, which is 6 volts. I'm happy with that. So I can just show 6 volts in there. I3 is what I want. And now I need to find the effective resistance of this thing, right? So I need to find the effective resistance of that thing. So, let's see, like I said, 6 volts here. So how do I find the effective resistance? I find it basically the same way we did last lesson. So this is the same sort of structure that we had previously, but previously we had equal resistors. This time they're all different, 1, 2, and 5/6 of an ohm. So we'll do the same steps, right, that we did previously, because the current has to come through here and has to come through either here or here and then into this guy. The way to figure out the effective resistance is first to find the effective resistance of the two objects in parallel, and then do the series part. So the last part is do the series, which is R11 plus R3, right? Or R parallel. I wrote parallel, and now I think calling it R11. I'm sorry. All right, so R parallel, we had a procedure to do that. That was add the inverses. So that's 1 over R parallel is equal to 1 over 1 ohm plus 1 over 2 ohms, which is equal to 1 over, or I guess this is multiplied this by 2 over 2. So we have 2 over 2 ohms plus 1 over 2 ohms. So that's 3 over 2 ohms, which means that our parallel is equal to 2/3 of an ohm. All right, so we have 2/3 of an ohm plus R3, which is 5/6 of an ohm. So if we multiply that by 2, we have 5/6 of an ohm, 4/6 of an ohm plus 5/6 of an ohm, which is equal to 9/6 of an ohm, which is equal to 3/2 of an ohm, 1.5 ohms. So we have 6 volts is equal to 1.5 ohms. Okay, so then we have to do this for I3, right? So if we divide by 3, we end up with 2 volts is equal to I3 times 1/2 of an ohm. Multiplied by 2, we have I3, or multiplied by 2 ohms, we have I3 is equal to 4 amperes. All right. So we're good with that. Now what we have to do is we have to use this I3 and whatever other information we can think of to figure out what I1 and I2 are. But we already have I3, so I3 is equal to 4 amperes. We'll have to find the other two some other method, or maybe even by the same method. I'm not sure. So let's see, what do we want to do? Well, we need to find first the voltage from here to here, right? I want to find the voltage from there to there. So you'll remember that one of the things that we did previously was the voltage drop over this part from here to here, and the volt is proportional to the voltage drop over that part, or in proportion to the resistances. So this is 2/3 of an ohm, and this is 5/6 of an ohm. So it's in proportional to those resistances. And since they're summed, this thing is just, what is that? I just said it. 3/2 of an ohm. So one thing I can do is I can say, I know that this is 3/2 of an ohm and it has 6 ohms, so, or 6 volts. And that's equal to, I want to find this delta V from here to here, so that's equal to this effective resistance are parallel, 2/3 of an ohm over this effective resistance of the entire thing, which is 3/2. So that ends up giving us 4/9 of an ohm. 4/9 of nothing, actually, because the ohms cancel. And then delta V is just 6 times this, which is, taking out the 3, 8/3 of a volt. Okay, so that's what we're looking to use. We already got that part. So the next part is we want to find the current through R1. Well, that's not going to be too difficult because we know what this delta V is. So we have 8/3 of a volt is equal to the I1 that we want times 1 ohm, right? So that means I1 is equal to, divide by 1, 8/3 of an ampere. Okay, so that's pretty reasonable. And we could do the same thing if we wanted to find R2, or we could use the junction rule, because that says what comes in must come out. And we have what comes out, which is 4 amperes. This is all for this point here, C, where I2 and I1 go in and come out as I3. Okay, so let's see. I have to got 4 amps, so that's good. Good. And then we have that's equal to 8/3 of an amp plus I2. That means I2 is 4/3 of an amp, because this is 12/3. 4 is equal to 12/3. Right, so 12 minus 8 is 4. So we end up there. Okay, so that gets us all of these things, and that better add up to 4. Let's see. Well, I mean, I just said it would, but 8 plus 4 is 12, divided by 3 is 5, or 4. So, oh, sorry. So that's all we had to do. So this is a little bit complicated, so we had to go through, and we had to do a lot of little things along our way to get the correct answer. But in the end, it was worth it. We were able to get results for all 3 of the resistors. Okay, thank you for this. I will come back in a couple minutes with the long one. Okay.